Guys, we are going to do Unit 6, Lesson 5 here. We're going to look at some trends in scatter plots. So which three go together? Why do they go together? Whoa, this line shouldn't be on here. Clear all objects. That line is not there. There we go. That line is not there. Wasn't supposed to be there. See, I can't do that to anything else. Sorry, guys. So that's what it should start out looking like. That red line I'm going to bring back here in just a minute. But anyway, which three go together? A, B, or C? A, B, C, D. Which three you want to put together? And then why? Some reasons that I've heard students say. One of them said B, C, and D. B, D, and C. Why? They're all going down from left to right. They all have a negative slope. If I drew a line, the slope would be negative. So B, C, and D, because they're all going down from left to right. So what about, I said, hey, C, A, and B, because they all got a line. They all got a red line on them. That's why. Okay. So another student said, I think, yeah, it was B, C, and D again, but the line with the angle of the line, the tilt, the slope of the line would be about the same. So they were saying B, D, and C, but they were saying because the slope of the line would be about the same. I was thinking somebody somehow. Okay, that's enough. I can't remember what else, but that's enough. Now, I do want to draw this line again because I want you to get used to drawing these. So all this whole lesson is about drawing lines. So you'll want to pause this video at times. See if you can trace over, draw a line on a paper, and then see if you get the same line. So we're going to draw lines of best fit is what I'm going to call them. A good fit line is what they call them. All these red lines kind of pass through the middle of all these dots, which means the distance. So if I drew this line and I made it perpendicular to this line, that line, distance, I want to get that. And then all of these distances, all of these, so all these red line distances, I would like for them to be, if I added them up, and then I did the same thing for green lines over here, and I did that, I did this green line, all of them above and below. That's what we're trying to do. All these lines, above and below. Eventually, we want those to cancel each other out as much as we can. So you want to kind of split this data in half. So if I was to draw this red line down here, I wouldn't draw it like this. That puts them all below the line. I wouldn't put it down through here where they're all above the line, right? Might move it around into this area. Now I'm going to simply count, hey, how many points are above it? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 above it, not touching it. I'm going to call him not touching it. 1, 2, 3, 4, 5, 6, 7. So 7 or 8 not touching it is touching 1, 2, 3, 4, 5 dots. So I didn't count these because it's literally touching those. So I didn't count those, but I got 8 and 7. I'm pretty much splitting the data in half. That's what this whole lesson is about, in a nutshell. And eventually, down the road, we're going to want these red lines up here, all of these, and all these green groups. When we add their distance up, we're going to get an R value. That's way down the road in probability and statistics in a class called probability and statistics. That's where that's going to come up. Okay, I didn't clear off any objects. Okay, we'll just leave them on here. So here are 2 lines. We're not going to leave them on there. We needed to draw these lines. I cleared all the ink, but I did not clear all the objects. So let's see how many other objects I need to clear. Any on this page? No, that's all good. Any here? I think I got that one in here. I think I've got them all now. There. Nope. Okay. Man, I was not ready for that. Okay. So we're going to be drawing lines. That's what you're going to be doing. Again, this is where I would pause it, put a piece of paper over this, draw a line of best fit. All you're trying to do is draw one line that cuts that data in half. And that's what I'm going to call that. I'm going to call that my best one. We could move it top to bottom. These can be different from each other. We don't all have to have the same one. I'm going to call that my line of best fit. Okay. You then compare yours to mine. Here we got some more. Again, I don't think this would be a line of best fit, even though it might put the same number above and below. I really don't think that's a good line of best fit because these points up here are way far away from it. So you want to try to get as many points as you can close to it. So we're trying to get it close to it, to as many points as we can. That's our goal. How many points can you get close to it? Okay. And that's what you want to do on this set. Get it close to them. As close as you can to as many points as you can. Okay. That's your goal. Okay. So in your own words, describe what a line of best fit is. Well, in my own words, the line that passes through the middle of the points. Okay. The line that cuts the points in half. That's what it is. So here, this is a fun little activity. We got two scatter plots. You got years and prices. What are these the prices of? Scatter plots show the year and prices of the same 13 used cars. So the same 13 used cars. So we got some used cars here. We want to know which one predicts the best model for this. So for how many cars is the modeling diagram a good prediction? So again, this word good prediction means close. Those that are close to. If you watch the last video 5 or 4, video 4, lesson 4, at the very end we talked about being close. That's a better prediction. So I might go, hey, on A, I think that one I think is close. I think that's close. Yeah, that one's close. He's close. He's close. He's close. So I might say only 6 of them are close. So I might say 6. Somebody else might go, no, I think this is pretty decent. I think he's pretty decent. I think he's okay. So I might say 9. Somewhere in there. You might argue this guy's not that close, but this guy isn't that close. So you might say 7. So 6 to 9, somewhere in there. Okay, something like that. You might want to say, nope, don't want to clear the ink. Just want to erase. That's all we want to do. Get the eraser going. So then, how many cars does the model underestimate? How many of them is the red line under? The red line is under this point, this point, this point, this point, this one, and this one. So 1, 2, 3, 4, 5, 6, 7. So it's under 7. How many is it an overestimate for? Well, which ones is the red line above? All of these. 1, 2, 3, 4, 5, 6. We know there were 13. If it's under for 7, it's got to be over for 6, right? So if we look at B, that's this one over here. This is about the only good point, I think. I think that's the only good estimate. Now, you might want to say this one is. Maybe, maybe not. You might want to call that guy it. So you might want to say 3, 1 to 3, somewhere in there, right? How many is the model an underestimate for? So we want to look up here. That was what I did in red a while ago. 1, 2, 3. And it's an overestimate. I'll move this so you guys can see that's actually what I'm talking about. Overestimate for the price. That's all these below it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. Also, we know there were 13, right? For how many cars does a prediction made by model and diagram A differ by more than 3,000? Now, it does say more than 3,000. So I should keep that in mind. By more than 3,000, but I want to show you what 3,000 is. That's this gap right here. All these lines are gapped off by 3,000. So where do I think that line, if I was to bring it over? Well, I think from here to here, from here to here. If I drew a straight line, the reason I can't draw the line straight is for this purpose. If I draw this line straight, I just went through this red dot. So that's 1. Then there's 2. This would be 3. This right here, I don't know. It's exactly 3,000. That's 4. So I might say 3 to 4. Whoops. So how many, whoops, come on thing. How many of this, how many cars does a prediction of the model and diagram A be more than 3,000? I'm going to call it 4. And now we'll go over here to B and look at it. So again, the gap is 3,000. I don't think that's one. I don't think those are. Ooh, this is close. That's really close. That one definitely is. That one definitely is. That one definitely is. That one definitely is. And that one definitely is. 1, 2, 3, 4, 5, 6. So I'm going to call that a bad one for 6. Trying to draw with the arrow, sorry. So that was 6. So which model does a better job? Which one has less? They're off by that. Model A. Now let's move on. So in this line, is this a decent line of best fit? I'm going to say no. I'm going to say that's a no. Why is that one a no? Too many points are down below it, right? You could say that. You could also say it's an overestimated prediction. The line overestimates. Too many points. Okay, so what happens if we draw a better line of best fit? Where might we draw a line that's a better line of best fit? Maybe I come down through here. I think that would be a better line of best fit. You draw yours wherever you want it. Is this a good line of best fit? Let's see. I think, I'm going to say, yeah, I think so. Well, we're going to undo that, aren't we? Yes, we are, right there. Yeah. It's got them on there. Or maybe you go, no, you can do better. It's a little, there's too many farther away on this top part. Like none of these are touching and then some of these are touching. Maybe you say no. Because some are touching at the top and none are touching at the bottom. Let's draw a better line of best fit. Where might we draw one that's better? Okay. Let's make our line of best fit through here. because now I got more dots touching the line. Maybe that's it. We're not going to do that part. And that's our summary. So let's talk about our summary. When a linear function fits data well, we say there is a linear association between the variables. For example, a relationship between height and weight. The 25 dogs with the function whose graph is shown by this. We say this is a positive because the slope of this line is positive, right? It's got a positive slope, positive association between dog's height and dog weight. Because knowledge about one variable helps predict the other variable, and when one variable increases, the other tends to increase as well. What do you think the association between the weight of a car and its fuel efficiency is? Well, we say this is negative because the slope of this line is negative between fuel efficiency and weight of a car, because knowledge about one variable helps predict one variable, and when one variable increases, the other tends to decrease. This phrasing here, where'd it go? When one variable increases, the other tends to increase. That's a positive association. And a negative association, when one variable increases, the other tends to decrease. So positive slope lines, one variable increases, the other tends to increase as well. Negative slope lines, one variable increases, the other tends to decrease. That's all we got.